Okie doke. Let's do some quiz review. Card number 1. Let's see what they have in store. Here is a function. F of x equals yada yada yada. Write the equation for the inverse. Okay, let's go. If you want to do this algebraically, you will switch x and y first. So you will say x equals the square root of y plus 2 cubed minus 1. And then you will reverse PEMDAS to solve for y, okay? So by now, you should be really comfortable if you're choosing the algebraic way with what to do and in what order and all of that. So if you're not, then I really urge you to try their table method, which is the way I'm going to do this. What we do is we set up a table like that, and we begin with just x in the first box. And we look at this function right here, and we see, what is it? X what? X plus 2. So, boop, we have a plus 2. Then we go, okay, x plus 2 is what? X plus 2 is cubed. Then we say x plus 2 cubed is what? Minus 1. So we have built our function here step by step, and now we will undo it. So we'll start with x in this box, and then we will do the opposite of what's above. So here is a minus 1. We'll start with a plus 1. That's cubed. We'll go with a cube root. And then that's plus 2, so we go minus 2. And that, my friends, is the inverse. How do we write it? We write f inverse of x equals the cube root of x plus 1 minus 2. Okay? Cool. Let's go look at the next card. Here's a function, q of x. Write the equation for the inverse. All right, let's do it. So again, we'll set up that table and build the function with x in the first box. And then we're going to see x is, the first thing is the 1/2 times 1/2. So you can also check in with PEMDAS. PEMDAS says look in the parentheses first. And then within the parentheses, we have multiplication and we have subtraction. But according to PEMDAS, multiplication comes before subtraction. So the 1/2 is first. The square root, you guys, acts as a parenthesis. Okay? Alrighty, 1/2 x. Then the 1/2 x is minus 1. And then the 1/2 x minus 1 is square rooted. So now to undo, start with x in the box right there on the right side. And the opposite of a square root is to square. So x squared, just the previous step with this added on. The opposite of minus 1 is plus 1. So we take the previous step with this added on. And the opposite of times 1/2 is divided by 1/2. Okay? However, anytime we have something and we're going to divide it by a fraction, we end up with something ugly that we don't actually want to deal with, all right? So what I would rather you do instead is take that something divided by 1/2 and keep, change, flip. Keep the something, change the division to multiplication, and flip the 1/2. 1/2 flipped is 2/1, or just 2. So in this step, instead of dividing by 1/2, I would multiply by 2. 2 times this previous step. And that's the inverse of that. How would I write it? I would write Q inverse of x. Okay, just that -1 looks a little bit intimidating and scary. And where did the -1 come from? It's not. It's just a notation that means the inverse of that. Okay? 2 times x squared plus 1. You can distribute the 2 or not. Doesn't matter. Okay. Now, part B said, determine the value of Q inverse of x when x is 2. So that's like plugging 2 in for x. X is 2, plug 2 in. Plug 2 into where? Into the inverse, because that's what the one that they said. So here I would say, let's change the color because there's too much going on now. For this one, I would say Q inverse of 2. That means I'm going to plug 2 in for x, is equal to 2 times 2 squared. Oh. Plus 1. So this is Q inverse of 2 equals 2 times 2 squared is 4. 4 plus 1 is 5. So it's 2 times 5. Q inverse of 2 equals 10. Okie doke. Let's go to the next one. Here's the graph of g of x. Does it have an inverse? Ooh, good question. To see if g has an inverse, so please note that this is going up and to the right forever. This is going down and to the left forever. And what I mean by that is that it never gets perfectly horizontal, never ever. It's always got a slight upward trajectory. And what that means is if I take a horizontal line and scan it across the function, I never actually touch that horizontal line more than once, all right? That is the definition of passing the horizontal line test. If you don't touch more than once. Passes, horizontal line test, therefore, that little symbol of 3 dots in the shape of a triangle means therefore. Therefore, g of x has an inverse. So yes. Okay. Here are some functions that do not pass. Your parabolas don't pass. Your absolute value functions don't pass. Your polynomials that do this kind of thing don't pass. Because these are all instances where a horizontal line across touches the function in more than one spot. See, 2 spots right there, 2 spots right there, 1, 2, 3, 4 spots right there. These are not functions, all right? I'm sorry, they are functions. Totally lied about that. They just don't have inverses. Okay, let's go back to here. If g of x has an inverse, sketch the graph of g inverse. If g doesn't have an inverse, explain why not. So looks like we're sketching. Here's how we sketch, all right? I take the points that they gave us. So here's one right here at 3, 0. Okay? Then here's another one at 11, 2. Here's another one at -5, -2. And because I know myself, and I know that's not going to be enough for me to see what's happening, I personally would take a couple of points closer as well. So maybe like 4, 1. And also maybe 2, -1. Okay, so with this, I will just switch the x's and the y's, okay? Because that's what inverses are. Inverses are x and y switched. So this 4, 1 is a 1, 4. 3, 0, 0, 3. 11, 2, 2, 11. -5, -2, -2, -5. 2, 1, -1, 2. So notice how the negatives don't change, just the position of the numbers changes. And now I'm going to plot these points. Okay, so let's start with 1, 4. 1, 4. Please remember, I have seen a few of you guys struggle here. The first number tells you how far right or left to go. Right if it's positive, left if it's negative. That number tells you how far up or down to go. Up if it's positive, down if it's negative. So 1, 4 means 1 to the right, 4 up. So 1 to the right, 4 up, okay? All right. 0, 3 means 0 to the right and 3 up. 2, 11, 2 to the right and 11 up. -2, -5, 2 to the left, down 5. Oh, another thing, you guys, that confuses you is the 0 that they put kind of in the middle at like -1. I've seen so many of you think this is where the 0 is. This indicates the origin is right there. I know it's weird. Just ignore it then, all right? If you're somebody who gets confused by that, please ignore that 0. Okay. Where did I leave off? -1, 2. Left 1, down 2. All right. And, oh no, something went wrong. Oh yeah, I went down 2. That's a positive 2. It should have gone up 2. -1, up 2. There we go. And now you guys, like, can you see how, at least for some of you, I'm sure, are like me. If you didn't have those 2 dots right there and all you saw was this dot, and this dot, I personally would not have known what's happening. So, but now that this is here, I can tell that it's this. All right? And look at this perfect reflection of that graph over the line y equals x. All right? That's how inverses go. Card number 3. Okay. Keep it going. Card number 4. Here are the graphs of 2 functions. Determine whether each function has an inverse and explain your thinking. Oh my gosh, we just talked about that right here. So I expect this to be a cakewalk now. We're going to take ourselves a horizontal line. Oh, this ruler. There we go. We're going to scan across the function and see if we ever touch it more than once. And this one for sure. 2 times right there. No inverse. This one right here, totally fine the whole time. Yes, inverse. Okay? What's my thinking? My thinking is horizontal line test. Okay? Number 9. Here is a function, yada yada. Select all the statements that must be true. Well, let's see. Let me tell you what I know about this function. This function is a cube root. So what I know about cube roots is that they have this kind of shape, meaning they go all the way left and all the way right and all the way up and all the way down. All right? They go everywhere. They don't just abruptly start out of nowhere. And then I also know that they have inverses, okay? And then I know that their inverses are cubic functions. So something that looks like that. As a matter of fact, you guys, we just did it. Number 9 literally could be like card number 3. You see it? They gave us a cubic function. We graphed the inverse, and the inverse was a... they gave us a cube root function. We graphed the inverse was a cubic function, all right? So let's take a look. The first one says that our inverse of x has a domain of x greater than or equal to 0. That means all the x values are only the ones that are positive or 0, no negatives, okay? That's not our situation, you guys. The cube root function and the cubic function, they are boundless. Oh, you can't see. They are boundless, all right? Up forever, left forever, down forever, right forever, everywhere forever, okay? They don't have a restriction. Their domain is all real numbers, okay? So that's not true. R inverse of x is equal to negative r of x? Highly doubt it. I highly doubt that a cube root function is going to equal the negative of a cube function. Like, no. It doesn't even make any sense. Let's keep going. They're saying that the inverse is 1/2 x cubed. Well, that I might believe. That I might believe, because I see a 2 times and now I see a 1/2. I see a cube root, now I see a cube. That could be true. However, I also know that the way these things present is unpredictable sometimes, so I'm not going to risk it, and I am going to check it. Start with x in the first box, and the first thing is to multiply by 2, so 2x, and then the second thing is to cube root, so cube root of 2x. And then now I start with x here and reverse it. So cube root was last, so now cubing is first. And then multiplying by 2 was first, so now it's last. And this is dividing by 2. I don't know how to write divide by 2. So x cubed divided by 2, which is the same. Here, let me write it on the side. X cubed divided by 2 is the same, because there's a 1 in front of that x, is the same as 1/2 x cubed. So finally, a true one. They're saying the point 2,4 is on the graph of the inverse. Well, now I have the inverse, so I can check, all right? I could put 2 in for x and see if I get 4. So 1/2 times 2 cubed. That's 1/2 times 8, which is 4. So 2,4 is on the graph, all right? I want to point out that if I didn't have the inverse at this point in the game, I wouldn't find the inverse just to plug in 2,4. I would not do that. Do you know what I would do? I would switch 2,4 to make 4,2 and plug it into the original function. Because remember, x and y switches between them. So if 2,4 is on the inverse, then 4,2 is on the original, okay? But I had the inverse, so I went for it. Now they're saying the point 4,2 is on the graph. Oh, I find it unlikely given how this panned out, but let's check it. 1/2 times 4 cubed. 4 cubed is a ginormous number. It is 64. And half of 64 is 32. So that one's not true. Okay. Here is a graph of a cube root function. Write an equation. Ooh. Let's do it. So I got myself a cube root function. They even tell me. They didn't have to. They sort of had to, because what if it was like a different one, but whatever. Let me tell you what I notice, okay, immediately. I notice, okay, so cube root. I notice that this guy's upside down. So I notice that there has been a reflection, okay? How? Because look, the normal cube root function, we've looked at it before. It goes up on the right, down to the left. This guy's doing the opposite of that. It's going down to the right, up to the left. This one is reflected, okay? So I've got myself a reflection, and I know when it comes to cube roots, horizontal, vertical reflection there's no distinction there. So I'm gonna go with vertical because it's the safest one, okay? Next, I notice that there is no scale. How do I notice that? Because the function from the center of it only grows one tall when you move one over. Like it's like a up one over one, down one over one. When it's up one over one or down one over one, whether it's a cube root, a square root, a parabola, or whatever, there's no scaling there, okay? Now, if it goes up 2 over 1, then there would be a scale, and the scale would be 2. If it goes up 3 over 1, the scale would be 3. So in this case, no scaling. And then finally, I notice that it has gone to the left one, and boop, 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 up 3. So now I'm going to put all of this into this. N of x equals a negative cube root of x plus 1 plus 3. All right, so the left one is a plus 1 with x in the radical. The up 3 is a plus 3 at the end, not in the radical. The reflection is a negative right there. And the fact that there's no scale means there's no number with the negative. It's just a negative 1. Boom, done. The reason that I say vertical reflections are safer is because if you wrote for me n of x equals the cube root of negative x plus 1 plus 3, you would be wrong. Because you would need parentheses here. We must separate any numbers being multiplied. We must separate them from the x and the shift, or else it's wrong, okay? And so just to not even deal with that nonsense, since I have the choice, I make it a vertical reflection. Okay, but if it was a square root and I had to make it a horizontal reflection, please, I would definitely remember to put parentheses around what came after it. Okay, I believe that I am short on time. What time is it? Let's see. Yep, it's 8:55. I gotta go. I'll do this on another one.